Welcome back, listeners, to another exciting episode of Operating Systems Crashcast. I'm Victor, and today we're diving into the world of real-time CPU scheduling. Sheila, are you ready to explore this critical aspect of operating systems?
Absolutely, Victor. Real-time CPU scheduling is a fascinating topic that plays a crucial role in many systems we rely on every day. Let's start by explaining what we mean by real-time systems.
Great idea, Sheila. Real-time systems are computing systems that have to respond to events or process data within specific time constraints. These systems are designed to guarantee that certain tasks will be completed within strict deadlines.
Exactly, Victor. And it's important to note that there are two main types of real-time systems: soft real-time systems and hard real-time systems. In soft real-time systems, missing an occasional deadline is undesirable but not catastrophic. For example, a video streaming service might be considered a soft real-time system.
That's a great example, Sheila. On the other hand, hard real-time systems have absolutely no tolerance for missed deadlines. Missing a deadline in a hard real-time system could lead to catastrophic consequences. Can you think of an example of a hard real-time system?
Certainly, Victor. A perfect example of a hard real-time system would be the computer systems in an airplane or the control systems in a nuclear power plant. In these cases, missing a deadline could lead to disastrous outcomes.
Excellent examples, Sheila. Now that we understand the basics of real-time systems, let's talk about how we schedule tasks in these systems. The most common approach is priority-based scheduling. Can you elaborate on that?
Of course, Victor. In priority-based scheduling, each task is assigned a priority. The scheduler then ensures that the highest priority task that's ready to run gets CPU time. This approach is particularly well suited for real-time systems because it allows us to give precedence to time-critical tasks.
That makes a lot of sense, Sheila, but how do we determine these priorities? Are there specific algorithms for this?
Indeed, there are, Victor. Two of the most important algorithms for real-time scheduling are rate monotonic scheduling and earliest deadline first scheduling. Let's start with rate monotonic scheduling. In this approach, priorities are assigned based on the frequency of the task. The more frequent the task, the higher its priority.
Interesting. So in rate monotonic scheduling, a task that needs to run every 10 milliseconds would have a higher priority than a task that runs every 100 milliseconds.
Exactly right, Victor. This approach works well for many real-time systems, especially when task periods are known in advance. However, it's not always optimal, which brings us to our other algorithm: earliest deadline first scheduling.
I can guess from the name that this one has to do with deadlines. How does it work?
You're on the right track, Victor. In earliest deadline first scheduling, the task with the nearest deadline gets the highest priority. This priority can change dynamically as time passes and deadlines approach. It's generally more optimal than rate monotonic scheduling, but it can be more complex to implement.
That makes sense, Sheila. It sounds like earliest deadline first might be particularly useful in systems where task deadlines can vary. Can you think of a real-world example where this might be useful?
Absolutely, Victor. A good example might be in autonomous vehicles. Different tasks might have different urgency levels depending on the current situation. For instance, applying brakes would suddenly become the highest priority task if an obstacle appeared in front of the vehicle.
That's a great example, Sheila. It really illustrates how critical real-time scheduling can be in modern systems. As we wrap up, what would you say are the key takeaways for our listeners about real-time CPU scheduling?
Great question, Victor. I'd say the key points to remember are: first, understand the difference between soft and hard real-time systems. Second, know that priority-based scheduling is fundamental to real-time systems. And finally, be familiar with rate monotonic and earliest deadline first scheduling algorithms, as these are commonly used in real-time systems.
Excellent summary, Sheila. Real-time CPU scheduling is a crucial aspect of many systems we interact with daily, from our smartphones to critical infrastructure. Understanding these concepts is essential for anyone working with or designing operating systems.
Absolutely, Victor. And for our listeners who might be preparing for interviews, remember that questions about real-time systems and scheduling are common. Being able to explain these concepts and discuss their applications can really set you apart.
Great point, Sheila. Well, that brings us to the end of today's episode. Thanks to all our listeners for tuning in to Operating Systems Crashcast. Until next time, keep those CPUs scheduling efficiently.